Let's do a problem. In the figure here, BC and AC are two equal chords of the circle with measures 12 cm each. So this is 12 centimeters and this is also 12 centimeters. The radius of the circle is given as 10 centimeters. We have to find the length of the chord AB. Let's discuss the approach for finding the length of the chord AB. So here we can explore the property that perpendicular from the center bisects the chord. And for that, let's mark the center as O. So this is our center O. Let's draw the perpendicular from the center OD to chord AB. We can join AO. So OD is perpendicular to AB and OA is the radius, so we can write the radius here as 10 centimeters. We know that AD will be half of AB because perpendicular from the center will bisect the chord. So if we can find AD, then twice AD will be AB. So to find AD, let's think of applying Pythagoras theorem in right triangle OAD. But in this right triangle, we do not know OD and AD. Let us think of some way of finding OD and AD and applying the Pythagoras theorem. Let us see if we can find another right angle triangle here where we can apply the Pythagoras theorem. For doing this, extend D to point C. So we have extended OD to point C here, and now let's see whether ADC is a right angle triangle or not. Now it is given in the question that chords BC and AC are equal in length. So in triangle ABC, we have opposite sides equal, so this is an isosceles triangle. And we know that D is midpoint of AB, so CD is the median. And we know the property that in an isosceles triangle, median is also the altitude. So that means CD will be perpendicular to AB, and that means this is a right angle triangle. One important point here, we can see that OC is the radius. So OC will be 10 centimeters. And if we can call this length OD here as X, then DC will be 10 minus X. Now we will apply the Pythagoras theorem in two right angle triangles discussed here, form an equation and solve the question. So in the first right angle triangle AOD, we have AO square is equal to OD square plus AD square. This implies in place of AO we can write 10 is equal to, in place of OD we can write X plus AD square as it is. Here we can form an expression for AD square equal to 100 minus X square, call this 1. Once again in right angle triangle ADC, square of the hypotenuse will be equal to sum of square of the other two sides. In place of AC, we can write 12, AD square as it is, and in place of DC, we can write 10 minus X as discussed. From here also, we can form an expression for AD square, call this second. From 1 and 2, we can see that their LHSs are same, so we will equate the RHSs and solve for X here, and we'll get X is equal to 2.8 centimeters. And if in 1 we put 2.8 centimeters in place of X, we can get the value of AD. So AD square will be equal to 100 minus 2.8 square. So AD from here we can calculate as 9.8 centimeters. As discussed, AB will be equal to twice AD. So that means 2 into 9.8 centimeters will be equal to 19.6 centimeters. This is our answer. So we applied the property of the chord here that perpendicular from the center bisects the chord to solve the problem.